Enable the documents. So I formally welcome you all, sir. Good afternoon, good evening, in fact, all the sir and madam, and happy puja. This is the puja week, so I'm sure a festive mood will be around. But we'll just take 1 hour, and you know the cadence of ours. So this session of Antardrishti is, as you all know, sir, it's a esteemed series in which we try to give various insightful interactions through various industry leaders. And basically, it is to design the sparks on the various new perspectives and encourage the deep reflections on the subject which are critical to the leadership success. Today, in the same series of Antardrishti, the 14th edition, we have the session focused on driving innovation in organization. But before we introduce the speaker or go forward, let me please call Sri Sanjay Dar sir, CGM HR L&D, for setting the context, sir, and then we'll move ahead, sir.
Thank you, Rajesh. I think I will take away 5 minutes valuable time from Vishwas Saab's time to set the context. Why we had this talk at this time is, despite the fact that it is pre-puja, and I understand a lot of people, have a challenge at this point of time, is because there's been a lot of discussion in our organization about how do we drive innovation, especially in the context of being a public sector organization, a large organization, and a lot of procedural hang-ups and things like that. So that was one issue that has been discussed by all of us senior management, including our chairman. I mean, he's been after it for quite some time. Then there was also this context of how the country is changing, how the nation is changing, how we are getting more self-reliant, and what is the underlying driver of the Atmanirbhar Bharat and Make in India and all those things. They are not mere slogans. A lot of things are happening in the country. And we are a part of the story because we are part of the steel sector. And we know, especially in the defense sector, a lot of things are happening and we are part of that story. So what is happening in those sectors is also relevant to us in terms of how do we need to align and gear up for the things. And more immediate trigger was, again, we had a leadership workshop just around 10 days back, not even 2 weeks, 28-29 September at MTI, where again that issue of driving innovation in the organization was discussed. And one specific case study that fired the imagination of all the people in that workshop was the case of Vande Bharat, and how we have taken a major leap in terms of self-sufficiency in modern railway coaches. So as we say, connecting the dots, I had been to ASCI Hyderabad for a management program quite some time back, and Professor Avasthi there had helped us by organizing a visit to Medha, where I came to know about their role in Vande Bharat. So I was already aware of that. So I thought when we are alive to the issue, when we are alive to the kind of work that is done in our country, driving innovation in the public sector, it is pertinent that we should get somebody who has been part of that story, who knows the story from multiple perspectives. That Rajesh will introduce Mr. Vishwas and explain what I meant by that, so that our people can also reinforce that self-belief that we can drive a lot of innovation in our organization, and we can do a lot to make our nation proud. So I think that was the context within which we are having this conversation now, and I'll hand it back over to Rajesh.
Thank you, sir. Thank you for setting the context, sir. So, आपने भूख जगा दी है सर लोगों में, सही बोलूं तो. But let me also directly introduce our speaker, sir. We'll make it short, sir. I will share your profile to the group also. Vishwas sir is currently leading the business development and strategic marketing at Medha Servo Drives Private Limited. which a company which is focusing on defense application and solar inverters, electric vehicles. But prior to joining Medha, Sir has also worked for a long stint, more than 15 years, around 15 years in General Motors Electric Division, which later became part of the Caterpillar Progress Rail, where he had the role of Regional Director for India and Sub-Saharan Africa. Sir has also a very rich experience with a tenure in the Ministry of Railways, where he has worked in the various key roles up to the level of the Joint Secretary. And Sir holds a degree in B in mechanical engineering and has also done his Master of Technology in Aerospace from IIT Mumbai. Sir is passionate about technology, particularly EVs and Make in India initiatives for defense, and enjoys the wildlife photography and robotics in his spare time, sir. So without further much ado, sir, I hand over to you, because we are all over here to listen to you, sir. Vishwas, sir.
Sure, sir. Thank you so much for the introduction, and Dhar sir, thank you so much for connecting the dots and setting the context. Now, without taking too much time, I will start my presentation. I will try to keep it as away as possible from the corporate pitch, but since it is a story about a company, little bit of corporate will come in, so please bear with me. I'll try it. And I also realize that it is the week of Puja, and everybody is eager to be with the families. So let's try to keep it interesting and short. And thank you so much for joining and giving us your valuable time. So with that, I am sharing my presentation. Are you able to see the presentation, or are you able to see the full screen, I think?
Yes, sir. Yes, sir. Thank you, sir.
Yes, sir, we are able to see it.
Okay. So start with the title slide, which is the story of Medha, innovation as the catalyst for success. So that's something that we truly believe in. And as I said, I don't want to bore you with our mission statements and vision and all that. But if you look at our website, it's one very significant thing. It says, enjoying innovation is there in our mission statement. So that's something that is a key to me. Where doing a job is one thing, and enjoying innovation in your job is another thing. And that's something that I believe Medha has built successfully as part of the company culture. And this is something that I will elaborate as we go through the slides, look at a few examples, understand what drove the story of Vande Bharat and other innovations. So this is starting with the brief company snapshot. And I'm sure some of you have probably seen this in your visits and may be aware of this. But essentially, Medha is a private company. It's a company with a global operation, though it's a predominantly Indian company. It's 100% owned in India. It was established in 1984 by just two technocrats. It was not established by financiers. It was not established by big business houses. It was established by two engineers whom people called crazy probably at that time for getting out of a government sector secure engineering job and trying to start a company. But they had this passion about electronics. They had this passion about doing something for the country at the cutting edge of technology. And that's how they started. Well, that vision was great, but then what do you start with? So they looked around and said, well, railways is the common man's transport. Railways also supports the economy. And that's why we will do something in the field of railways. Easier said than done, because in a government system, to enter as a vendor, whatever you may be intelligent, you may be smart, you may have the latest technology, whatever, it's very difficult. So I remember the days when our founder members used to share with me that they went pillar to post asking a question, what is your pain point? So railways, there were many pain points, but then they latched on to one which was simple in terms of concept, that there is a speed time recorder on every locomotive to record primarily how fast the driver is going at a given point. And that is because whether he's following the rules of speed regulation on railways. And this is very important for accidents, etc. So you'll not believe that in 1984, the technology which was 40 years old at that point of time was still being imported in the country. So this was a small speed time recorder, which was wax paper and stylus based. You can imagine, I mean, in the age of electronics, we were doing speed recorders, wax paper and stylus we were using in Indian Railways. And I was part of Indian Railways at that time. So I've seen it, held it with my own hands. I know how many problems are there with it. The rolls would go missing. In an accident, the roll would tear off. The drivers would tamper the roll and say, well, I'll show the speed little less than what I was actually driving, etc., etc. All you have to do is bend the needle downwards. So the graph records downwards. So, all sorts of problems were there. So my founders went and made an electronic solid state device, which recorded the speed, which interfaced with the computer, with the electronics on the locomotive, recorded the speed, and it could be downloaded with a laptop in those days. So it became a hit. It was reliable, it was rugged, and it was easy to use. So that was the beginning of Meta in the rail world. And with that, then Railways thought, well, you know what, guys, we have this another problem. So try a governor, because we are losing a lot of fuel when we notch up. When we increase the power of the locomotive, fuel gets wasted because it gets thrown up unregulated. So we did a mechano-electronic governor. Then we did a control system. So you see in the second row here on the right-hand side, the rolling stock equipment. Let me just put up a pointer so I can. So you can see here the rolling stock equipment. So slowly we progress from a small speed time recorder to a complete control system and traction system of the locomotive. And I will talk more about that a little bit in the later slides, not waste too much time on this slide for just talking about products. But today, if you look at any locomotive in the railways, any rail platform for that matter, right from high-speed expresses to freight locomotives to metros, there is our technology in those locomotives. So that's something that we have achieved from 1984 to now, and we are reasonably proud of it. Then we obviously moved to more complex systems, which are signaling systems. These signaling systems were actually, they have to be very high level of reliability, and that's called SIL4, SIL4 level. So where each decision made by the system has to be validated by 3 more systems. So within the system. So that kind of a cross-check has to be there. So this is used extensively in the signaling systems in the railways and yards. And then you have all heard about Kavach. It is being implemented. So accidents, head-on collisions are still happening where the Kavach is not implemented. But Kavach is something which will stop head-on collisions by sensing each other's presence. There are 2 trains on the same track. They will sense the presence of each other through radio technology. And that's the product which has been implemented, and it is helping railways to avoid accidents. 2,000 kilometers already been done. Railways has 64,000 kilometers. They have to find the budget. They're slowly doing it. But I believe the ministers announced 20,000 kilometers will be done this year. So that's a great step towards safety that Indian Railways is taking, and we are a small part of that story. Then we started leveraging what we have to other products in other fields. Forget railways. Railways, we did a lot of things, but then that knowledge base which we built up, can we not use it for things like solar inverters? Because ultimately, inverter is an inverter. Whether it's inverting power required for driving the motors on the railways, or whether it's inverters required to turn the solar power into usable electric energy. So inverters essentially will be similar in principle. So we leveraged our knowledge in that area. And so today we are one of the only ones in the country who does a 3.85 megawatt large central inverter, totally done in the country. And then, of course, we turned our attention to electric mobility. So, and I'll talk about electric mobility, so I'll not talk too much about it, but from 5-ton gross vehicle weight to 65-ton mining trucks, we have propulsion systems, the drive systems for all of them. We have developed those, and we have tested those, and we have applied those, and we have gotten them certified. And most of the OEMs are today, they've started working with us. So that's about just what the company does. There's something I cannot show on this slide. That's the defense area. I'm not supposed to publicly talk too much about the defense projects. We have certain constraints there. I hope you understand. But in defense too, similar situation existed. And I am going to give one example because it's generically known. It has been talked about in newspapers. So I will talk about it a little later in the slides. Similar situation to the Indian Railways. There was a stronghold of foreigners on the technology being used. And it is still there. And we are trying to break that. So along with the efforts from the Navy, the Army, we are trying to break that stronghold. So that's where how Medha stands when it comes to what we do. However, what started the story in 1984, what took it forward was the strong R&D focus of the company. And when I say strong R&D focus, I was just mentioning before everyone joined, this company is headed by a managing director, Mr. Kashyap Reddy, who does not bother about the revenue. You will be surprised. He does not follow up on the revenue. He does not look at what are the sales happening. He only looks after R&D. He looks after R&D and administration of the company. Of course, he does look at the revenue a little bit because incentives and employee satisfaction, everything is linked to that. So he does look at that, but primarily he looks after R&D and he heads the R&D. He's hands-on. He sits and reviews every month on every department, every product, looks at what is the customer feedback, and then goes into a detailed analysis. I mean, at one point of time, once my colleagues, GMs from R&D were tied up in another event, and I was called for an emergency meeting at the naval headquarters. Me and my managing director, we handled that entire meeting, right from commercials to R&D. That's the passion that we have, which we get into, and that shows when you look at the company. So with that, then we have been able to achieve some revenue. I'll talk about it a little bit. The slide shows the employee strength has grown. But what is important to me is that R&D strength has grown from about 10 people to 1,000 plus people today. And if you look at the ratio of employees, total employees to R&D, I think we have one of the largest in the country. So this is something which is key to our presence in such a technology challenging environment. Then, of course, from just being in one country, we have grown to 7 countries. But that's not important to me. Again, what's important is every year we spend 7 to 10% of our entire revenue on R&D. This is something which is, again, even the major OEMs who come to us to have EV discussions, they're shocked to see that figure. But that's the level of commitment the management and the company has. So I will go to just quickly a global presence. I hope you are able to see the slide which shows. So, mainly we are an Indian company, so everything is in Hyderabad. We've got R&D factories, we've got manufacturing, we have a lot of presence in Hyderabad. There are 5 facilities in Hyderabad, but we have expanded. And usually, especially in the public sector, what you will see is private companies who deal with the public sector, they go tie up with companies abroad and say, well, we will bring you that technology. We are exactly the reverse. We have gone abroad, purchased companies, had joint ventures, and we take our technology from India to those countries. So this is something which is interesting, and I don't think it's very common. And that certainly helps our Indian image to be improved outside as well. We come to know what are the benchmarks where our products need to stand shoulder to shoulder, if not better than those products in those countries. So that's the advantage we get out of this global presence. And I'll be sharing the slide deck so you can look at all the details of where we are. I'll not repeat it. I'll quickly go to what we think is a measure of success. So if we look at Medha growth from 1984 to present, is measure of success the revenue, which was less than 1 crore, which has gone to 3,500 crores? No, because sale is 30, 40 times more than us. So what am I talking about revenue in front of you people? You guys are the masters of revenue in a government sector, excellent revenue. So no, I don't think that's the measure of success. Is it staff strength? We were from 15, we went to more than 5,500. I don't think that's a measure as well, because people even who have low-tech jobs, low-tech companies who provide services, they also have lots of manpower. So that's not a measure of success necessarily, in our view. A number of facilities, again, no, I don't think that's a measure of success. Global presence, no, that's not either. Global product supply, we supply product in 50 countries now through our subsidiaries, but no, that's not the measure of success, I think. A big no. So I think those are the byproducts of success. They are not a measure in Meta's view. These are the byproducts. These will come. I'm sure all of us have seen this movie called Three Idiots. There, a profound statement is made. Excellence, you must have excellence. Kamyabi aapke piche bhagegi. Right? Baba Rancho Das says that. Rancho says that. So yeah, that's something like akin to our philosophy. We look at, these things are something that will happen if we have other ingredients. So what are those other ingredients? Now, before I answer that question, I'll answer at the end of the presentation. What is our view on what is success? So let's look at what we have been doing and why we have been able to sustain some innovation. Now, this is a basic point, sir, in my view. Many startups are there, brilliant startups are there, as we are all aware. Thousands of startups are there in our country, but we are also aware 99% of them fail. Is that right? Why? Because they do not, in my personal view, complete the cycle of sustained innovation. What is that cycle? First, we must have good R&D, which I believe, we as Indians are really brainy people compared to anybody in the world. We are more resourceful, we are more innovative inherently. And we have good R&D capabilities. But then do we follow that up with a good manufacturing support, a good vendor base, a good supply chain? So we have under our roof in one company, a very sophisticated manufacturing base also. Right from PCBs to the final product, we do it all. We design it, we develop it, we manufacture it, we test it. We test it first at component level, sub-component level. When the PCB is made, it gets tested with special jigs, which we design because we are the designers of the PCB too. So we know what that product is supposed to perform. So we do those jigs. And then when the product is done, our products are megawatt level products, most of them. So can we release them and make the customers guinea pigs in trials? No. We have the philosophy that we'll test the product to death, put out all the bugs before I even take it out to the field. So we have these comprehensive testing laboratories. You can see here a large test bed, which is capable of testing motors up to 1 megawatt. And we can do even combinations, like the Vande Bharat has 4 motors on one particular coach, under one particular coach. We can test that whole combination. And it's important because we have to care about wheel slips, etc. Then on electric locomotives, we have this phenomena happening that when an electric locomotive works, it is supposed to get 25 kilovolts voltage constantly from the line. But in the practical world, it doesn't happen. When another train goes and draws power suddenly, or one train comes and is regenerating power into the overhead grid, it actually fluctuates the voltage from 16 kilovolts to 32 kilovolts instead of 25. So can anybody simulate this in the lab? No. So we went and actually took a line from railways with their permission into our test facility and said, we will test your product in a real world condition. And we do the same for electric vehicles, etc. So we have extensive test beds. And then we get the certification done. Certification, many people look at as a paper exercise. No, it's not. It tells you that your product is of a quality which can be trusted. So this is an important cycle. And what we need to realize is many startups or many medium-sized companies do this cycle, but then they stop. We cannot stop. We have to keep this cycle continuously going. That's the secret. We take continuous feedback from the field, from our service teams, from our customer. Every month there is a review, and then we go back to the drawing board sometimes if required. We do next versions. We do improvements. And that's the key to the sustained innovation cycle. And this is something that is well established at Medha right from day one. And that's one of the ingredients of a sustained innovation, of good innovation. Now, let's come to the very famous Vande Bharat Express, which is close to everybody's heart. As an Indian, I'm very proud. Anytime I hear that name or I see that train passing somewhere. Today, just as an example, today I saw a very interesting video which showed on the Rewari line a steam locomotive passing the Vande Bharat Express. If anyone of you are interested, let me know. I'll share that video later. It came to me on WhatsApp through some of my friends. I'm sure it will circulate later. But a steam locomotive passing Vande Bharat Express at 160 kilometers, running at 160 kilometers per hour, that's something what is unique to India. That shows the character of India. That also talks about the challenges we have for new technology in India. So what is Vande Bharat Express? Vande Bharat Express is most of us know it, but just for someone who may not be aware, it's a premier semi-high speed train set. What is train set? I'll talk about it a little later. But this train set, why is it so important? Because it is something that only global players had before, other countries had before. We never had train sets. And today we have our own train sets. Several of them are running around the country, and they cost much lower than the European American benchmarks. And not only this whole design took place in 18 months. Now, the credit goes to Mr. Mani, his team at ICF, Indian Railways for enabling them, and of course, to our R&D to work closely with them to make that product happen. And I'll talk about that story a little bit shortly. So I consider this a shining example of collaborative effort between private industry and government industry. Now, though we call it a collaborative effort, let us remember, nothing is easy in our set of rules. And I know I work for government, I am working for private. I've looked at both from outside. So is it possible for any one of us to go and say, hey, you are my partner, do something for me? No. You have to go through tenders. You have to go through RFPs. You have to go through lots of processes, MOUs, and God knows what. So ton of paperwork, but it is possible. It's not impossible. And we have made it possible by understanding how our customer works, what are their constraints, what are their problems, and how we can enable them. And it's not always about money, as you will see. And that helps, because if you are ultimately trying for revenue out of this, right at the first go, people will be suspicious and they will not even work with us. So this is something that we have to keep in mind. So how did the collaboration go actually? Briefly, I'll show. So design of high-speed fabricated bogie. Indian Railways did not even have. Now, when we say bogie, it is basically this portion, which is under what generally is known as the bogie. What we have, what is below that is a bogie. So bogie is basically the set of wheels on which motors are mounted and they can move around so that we can go, so the train can move along the curves. So those are bogies. Indian Railways said, yeah, you have the control system, you have the traction control system, but I don't have a bogie. How do I make this product? So we said, we'll solve your problem. So we designed a high-speed fabricated bogie in collaboration with a European firm. Could Indian Railways have the freedom to go and pick up a European firm? No, we solved that problem. We did that collaboration. We put engineers to work with, because just if we had taken a design from Europe, it would be horrendously expensive. Plus, we will learn nothing. So we did a joint exercise. We picked up we actually worked with a firm to do this design of the high-speed bogie. And then we gave it to Indian Railways to manufacture. Today, they have enabled 2 other vendors to manufacture this. So it's not all about money. It's about enabling that technology. Same thing when it comes to, people said, well, the train will run at 160 kph. It has to be nice and aerodynamic. We don't have ability to do anything in composites. Our vendors are all steel experts. So we again developed a vendor. We did the nose cone design. We helped Indian Railways. Again, today we don't supply the nose cone. We never supplied the nose cone. Not a single nose cone was supplied by Meda. It was to enable that project. Then interiors, which go inside, the seats, the aisles, the facilities, the pantry. Again, we are not a company which does that, but we helped them design all this. We found vendors, we collaborated with vendors. Why? Because this project could only be world-class if it had fantastic interiors as well. Again, we have not sold a single seat to Indian Railways. It's just a support to the project. Then, of course, our area of expertise, train control management system. So this train has 32 microprocessors on it. And all of them talk to each other through this train control management system. So the crew does anything. He wants to apply brakes, he wants to apply open doors, he wants to increase the speed, decrease the speed, everything the train control management system does in interaction with the crew. Then, of course, we have the crew control interface, control cabinets, propulsion system. So when I say propulsion system, it is everything from the pantograph, which takes the power, then transformers and everything that it feeds to the wheels, right up to that. Everything in between is ours. That is our forte. We designed it, but it wasn't done in a day, not in 18 months. There is a story behind that. But here we see the collaborative effort that I was talking about. And it's not all about money. Again, key phase, it's not all about money all the time. So what led to Vande Bharat Express? So let's rewind a little. So we saw what is Vande Bharat Express. What led to Vande Bharat Express? So there is a concept called overpowering a train in Indian Railways. So we have to realize how Indian Railway trains work. There are no separate tracks for freight trains and passenger trains. I think we all know that. We see many times that our trains are waiting on stations, other train passes, some freight train passes, then our train goes. So that is because freight trains and passenger trains run on the same track. So passenger trains have to be run as fast as possible to give more space to goods trains, because railways ultimately makes more money from freight. So how do you run passenger trains fast? How do you also run freight trains fast? So how to run freight train fast is not so easy, because you can't do a train set there. You can't have powering wagons. So people said, well, at least let us run passenger trains fast. So how can we do those? Can we put more power, more locomotives? So now you can see here in the graphic, there is a locomotive in the front of the train, and then there are coaches. So you could put 2 locomotives, 3 locomotives. It's been done. So your train has more power, it runs faster. But it's very, very inconvenient, sometimes dangerous, because a lot of power is pulling at the front of the train. So what is actually required is a train set. What it means is there is no locomotive in this train. There are multiple power takeoff points which actually power the motor. So every alternate coach in a 16 train Vande Bharat Express is a powered coach. So this is a concept. So you actually have, if you had put 2 locomotives, your Vande Bharat has almost 2 times or 3 times the more power in that train set. So what happens? We are able to sustain 160 kph speed and shorten the time. As an example, Varanasi to Delhi or Delhi to Varanasi used to be a more than 14 to 16 hours journey at one point of time. This train does it round trip in less than 16 hours. So that's the power. So that's called overpowering. Well, that's great. So, well, what's the problem then? Let's do a train set. This was the thinking. Obviously, the think tank says that. But the problem is train sets to be developed first. Where is the propulsion system? Where is the heart of the train? The propulsion system is not available in the country. So fine, let's get it. So global OEM said, yeah, sure, buy our product. We'll give you propulsion systems. Oh no, we want it to be manufactured in India. We want to make our own train sets. No. There are too many problems. So all the naysaying started. So when India talked about making train sets in India, there was an outcry. People said it will take a decade at least for you to design something. Second, no Indian company has the capability for any kind of propulsion system. No experience or proven record. It will never be as safe as those in North America or European. These are the voices were heard. and naturally created a lot of doubts. But then, so this story started of Vande Bharat long before actually Vande Bharat design was started. And that's what I want to emphasize. So if you look at the hurdles of the technology, so locomotive technology is simpler compared to a train set. Even that was not available in the country. So what is there in that technology? There is this overhead line. There is one pantograph which takes the power to a transformer. The transformer feeds it to rectifier. Now this is not a simple rectifier. It has to be a three-phase inverter and smart inverter for that matter. It has to create certain frequencies and amplitude to drive the motors. And these motors have to be synchronized. You can't have one motor turning even 5 RPM more than the other motor. Then you will have derailments. So minimum 4 and maximum 6 motors in terms of a locomotive have to be synchronized properly. So this is something which is a very, very critical technology. And not only you can synchronize, you cannot have extensive wheel slips because you will again rub the rails and have derailments. At the same time, you cannot have zero wheel slip, because if you do zero wheel slip, then it is iron wheels on iron rails and friction coefficient is only 18%, 18%. So if your locomotive weighs 100 tons, your pulling power is only 18 tons, to keep it simple. So you know how much pulling power we put on a freight train with the same wheels and same rails? 44 tons. So where is 18 and where is 44? How is that possible? That is possible to allow the wheels to creep a little bit, spin a little bit, slightly, so that rolling friction and standard friction gets combined. So that's an art. Only 5 companies in the world have it, and we are one of them. So this is something that was developed over years. And this is critical technology which nobody gave. So if you look at the propulsion system, which is this red circle here, is called the propulsion system. Okay? The rectifiers, inverters, the motors, all put together is a propulsion system. 25% of a locomotive manufactured in the country in terms of cost is this system. And if you put all other electricals and auxiliaries into it, 40% of the cost is this systems. And where was this coming from? All from, like, even I'm part of the culprit. I worked for a foreign company. So I used to sell these, make 40% of every locomotive that Indian Railways made. And this is when technology transfer was given. Technology transfer, how to make a locomotive, was taken by Indian Railways from General Motors, from Bombardier, from Alstom. In spite of that, they had to import all this. Why? Because there was no capability in the country. So in 2004, MEDA took up the challenge of doing an AC-AC traction control system, which is the heart of any modern locomotive platforms, locomotive and train platforms today. Then started the pain. So pain of innovation, see the sad person there. Why? Because first, to go to a train set level of propulsion system, first we have to do at least a locomotive system. So we went to railways and said, well, we will replicate what you are importing from General Motors and from Bombardier, etc. So they said, fine, you think you are capable. We don't think that's happening, but here's a purchase order. If you are successful, we'll buy it. 2 numbers, 2 quantity. Okay. So it took 4 years to design, develop, manufacture, test. We had 0 revenue in that period. Nothing. No sharing of development cost by customer. Only a purchase order to supply 2 units. That too if we are successful. Nobody even knew how to measure whether that system is deemed successful. But at least there was a benchmark. There was an imported system performance. So we said we'll match that or better it. Developmental cost outweighed the purchase order by a magnitude of like 20, 30, 40 times maybe. So break-even was not even in sight with 2 units. 16 to 18-hour workdays with everybody doing software, hardware. But not only this, we also focused on vendor development. Why? This is a crucial point. Even when we did not know that there would be follow-up orders, we did this because the product cannot be sustainable. Anybody can do one system in the garage, but then how am I going to do 1,000 locomotives if required? This is the approach that was there. And I was very fortunate that our management had that wisdom at that point of time. When they had nothing, they literally had no money to pay salaries to employees at one point of time. But we were developing vendors. We were putting through a supply chain with the surety, with the vision that this will be a successful product one day. So that's part of innovation, and that's part of pain of innovation. Second part is the IP. People worked for us, some of them quit. We don't have a very high turnover, but it happens sometimes. So our IP had to be protected. Nobody should be able to just duplicate it. That's another pain of innovation. So we protected it by having very specific controls on how information gets shared within and outside the company. Our internet is not connected to our R&D servers. They are totally physically separate. So when we started working with defense, they were shocked to see that whatever they were going to specify as information security, we were better than that. So nothing could actually go out from the company unless a GM level person or the managing director level person authorized it. I'm sharing all this so that these are all the ingredients which go towards how you successfully innovate. And now, after we innovated and somehow got through that difficult phase of making a locomotive traction control system, then the journey started. So in 2000, the journey started. We did a AC/DC diesel locomotive traction control system first. Then we went to AC/AC diesel traction. This is what I was talking about, a very difficult one. 5-6 companies in the world have it. It's a difficult one. We did that. Then we went to electric locomotive traction. So that is when we take 25 kV and do it. Not just carry a diesel engine aboard, but take it from 25 kV. It has its own hazards. It's a safety hazard as well. We have to very carefully handle that much power and that much voltage. Then we did diesel multiple unit trains like Chennai DMUs, then EMU trains like Mumbai locals, we have all seen them. And then finally, we graduated to Vande Bharat set. So this is a journey which on the left-hand side, so this is something that we have achieved, and that is called customer confidence. Now coming to another aspect of this whole thing. I briefly mentioned in the earlier slide, there is a famous dialogue in one of the English movies, I forget which one, but the character comes, he's a salesman. He says, help me help you. What do you mean by that? Help me to understand what are your problems and how I can solve them. So that's the help me help you principle. So where did it get put in this program by us? So we identified, so we said we can do the propulsion system. We can do the motors, we can do the pantograph, we can do inverters, we can do transformers, all those things. But are there any gaps to make the program a success? Yes, there were gaps. Mechanical technology, bogies were not there. Composite nose cones could not be there. Then world-class interiors were not there, as I mentioned. So we tied up. We actually spent our money initially. And I mean, even why initially, it is spent once for all because Railways doesn't reimburse design effort. So we did all that and we enabled. We sometimes gave things free to Indian Railways, designs, sometimes with a very nominal cost because of tender conditions. And we did that. And we put almost 100 engineers constantly working alongside ICF at their facility with this vision that Mr. Mani and his team had, that we will design and produce a train set before 2018. So it was done, 2018, and the train set is called Train 18 by Indian Railways, not Vande Bharat initially. It's called Train 18 because it was launched to be launched in 2018. It was to be designed in 18 months, and which was done. Then the testing started extensively, and in February 2019, the Honorable Prime Minister flagged off the first set. This is an achievement, which is a great achievement by a government company, Indian Railways unit, which produces trains, is ICF. And that's how we collaborated with them, and that's how we enabled them. All this, of course, took place through tenders. They had to go in EOIs. Then we said, yes, we are interested in working with you on this. here is our credentials, here is our content that we will bring, here is what we'll help you to design. So we had to craft all that along with them, cross all those hurdles, and then come into. And this is feasible, sir. Now this is being done by more and more people. If you look at one of the news announcements that came in with my name a few weeks ago, it was with Garden Reach Shipbuilders, where we have done a collaboration. We will be co-developing products. Why they have done that? Because they know that we can move faster on some areas, and we can do collaborations and bring that knowledge into the party. So that's something that they don't have ability to do, being a government system so fast. So that's the kind of leverage that now the companies are doing. And we started that with the Vande Bharat, that trend. So what is the advantage ultimately? See, nothing is a charity. Everybody has to gain some money. We all have bosses who will say, ultimately, we have to pay our employees, we have to pay our taxes, we have to earn some money. So ultimately, with all that exercise, Medha has put in 30 plus Vande Bharat train sets into production. We have supplied them to ICF, and Indian Railways is running 30 plus Vande Bharat trains today, and they plan to run more than 100 Vande Bharat trains. So that's revenue ultimately, but it goes through a very difficult path in the beginning. So now coming to another area, electric vehicle drivetrain credits. Similar story, though of course here we don't work with the government. The story was the same. When government said, well, let us promote electric vehicles to help the environment in the country, they even offered a subsidy. So almost substantial subsidy, 30-40% of the vehicle cost. And I'm talking about heavy commercial vehicles only, not cars. I'm talking about buses and trucks. It was offered as a subsidy by the government initially. And what did the OEMs do? Major OEMs rushed to Dana, rushed to Prestolite, rushed to China, tied up. We will get your control system and we'll make our vehicles. I don't blame them. There was nothing in the country. So what they did was not wrong. It was needed at that point of time. But somewhere that mindset has to change. That is what we decided to do. In 2019, we were the first ones in the country to develop an entire propulsion kit. Now, having done megawatts of propulsion kits, this was not too difficult. But this has challenges as well. If you look at the components that are needed for a bus, so vehicle control unit, motor controller, battery pack, lithium-ion battery pack, and permanent magnet type of motor, which is 95% efficient. This is what a vehicle needs. Railways doesn't need that because Railways has a permanent source of power overhead. These guys run on battery. So you need that efficiency. You need that optimization. So we designed it from scratch. We built it, and today we have got all these types of vehicles which have been integrated. You can see this is the smallest, a van, and this is the largest. It's a 65-ton mining truck. So we have systems which can directly go on this, and we pioneered the retrofits because new would take time to come. Today, what we have found, and I'll show as the last slide in another 5 minutes, that there is the possibility to retrofit mining trucks and gain operational advantage in terms of cost. So this is something which very interestingly has come out. Again, our innovative mindset and the mindset, it has been 5 years. How much revenue have we made out of EV? Maybe 10% of our revenue after 5 years. But we are at it, and that revenue will continue to come. And that's the mindset that's there. So here's the mining truck. So we did actually trials. We converted a Ashok Leyland truck on our own. A mining customer gave it to us. We ran it in their mines. Now this truck is actually meant to be a surface tipper. It is not meant for deep mining. But they ran it in their mine, and they took it from the barite level to the yard. They did several trips. Now the cycle was interesting. They were doing about 20 trips a day with only 9 kilometers turnover. So we ran this truck in rain, 2 months of rain, and we collected data. And then we extrapolated and did a business case which shows, and Professor Awasthi is very familiar with it. It shows that if you start with a diesel truck, you continue the diesel operation, year 1, year 2, year 3, year 4, your diesel cost is going to go on increasing. Now, even with the Achhe Din, if we look at the diesel cost, it has increased 8 to 10% a year, right? So against that. So these people on a 55-ton truck are spending almost 170 or 180 rupees per kilometer. That is their cost only on fuel. I'm not even counting maintenance and drivers. If we go to electric, that cost comes down to 110 in the beginning and then even goes down further as the amortization kicks in. So this is an interesting business case that we are doing, and we are working very closely with Professor Awasthi and ASCII team to promote this. And we are very close to starting a pilot on this with one of the coal companies. So now my last example is the country has submarines. Submarines are a very precious asset. The submarine has only one motor, and it is between 3 to 5 megawatts, huge motor. If I talk dimensions, the diameter of the motor will be 3 to 4 meters. Can you imagine that? It is like as tall as a room. So this motor is always been imported, either from the Russians, from the Germans, or from French, depending on the original supplier of the submarine. We have, even today, there is no one who has come forward from these OEMs to set up a facility, even to just manufacture it in India. Forget about design in India. So what happens is, this submarine, when something happens to that motor, it has to be cut out of the hull and repaired. And for repairing, it has to be sent either to France or to Germany or to Russia. So 1.5 years, our precious submarine is lost. It sits in a dock. It's nice for our enemies, right? So we decided that we need to look into this area. We are used to doing high megawatt motors. We are used to doing permanent magnet motors in the EV side on a smaller size. Let us combine our knowledge again and attempt this. So in 2022, we started talking to everybody, naval dockyard, headquarters. Nobody said, well, go ahead and do it. We'll give you a project. So we said, fine, we'll do our own project. We'll start. So we started. We gained so much knowledge in the process that ultimately we were able to convince everybody in power to start a joint project with Mazagon Docks Limited. So even in that project, what helped was more than 50% of the cost of development is by Medha. Remaining less than 50% is by Mazagon Docks. And this is the kind of initiative that we have taken. So India will now become one of the 4 to 5 nations in the world to have submarine motor capability. This is something which is again a proud moment as an Indian for all of us. And we will all be able to celebrate and feel proud probably by middle of next year. Second quarter next year is when we will put this motor on test bench. So this is again something that innovation brings us. That brings us to one of my final slides, which says, you remember we talked about what is the measure of success. So here's a tape measure that's symbolizing these points which I put on the right side. So why we think we are successful? Not because of the revenue. There are multiple companies which may have more revenue than us. There are many companies which have more manpower than us, size bigger than us. In fact, everybody we compete with, Siemens, General Motors, Bombardier, Alstom, they're all giants in their fields. They're all multinationals. We have the market share against them. Why? Because we think we are successful. We have put up a sustained culture of innovation, technology, and quality. These three are the pillars. We will see that those are there even on our website, but that's not just a lip service. It's a commitment by our management. And we are encouraged. How do we encourage this? Like I said, 10% of our revenue. So you can imagine almost 200 crores a couple of years ago. And today it may be 300 crores. We do not link to any particular project. It is for studies. It is for trying out things. People are encouraged to make and break things. This, and our MD never says, okay, when is my money going to be recovered? No. Ultimately, the business leaders like me do that. We amortize in the long run. But it is never a pressure on the R&D team saying, tomorrow your product must start, ringing the cash register. No. So that is a success for us. It's a sustainable culture. The youngest member of our team sits in front of me and my MD and puts up ideas boldly. because he doesn't have to fear that he may fail and revenue loss may be there. So this is a success for us. Willingness and ability to innovate without immediate commercial advantage. So these 2 points are linked, top and the bottom. So first and second point are linked. And then the third important aspect of the success. I talked very briefly about people leaving us. Attrition rates. Our attrition rates are less than 5%, close to 2% most of the year. And people who leave us many times come back and join. Why? Because we have been able to generate this passion about innovation. People are proud to say, well, I may make money or not. A software engineer may make money from, does he make Vande Bharat Express? Can I tell my family proudly that Vande Bharat Express? So in Tata said, we also make steel, right? Their tagline. And SAIL has such wonderful products. Not many people would know those, but we ourselves can feel proud that we are part of that story. Or someday my children, my grandchildren will know that I have my hand. Like I'm personally successful with, consider myself successful in one particular aspect. I had a little bit of, let's say, squirrel's share in designing of the light combat aircraft during my master's days. So that's kind of gels with how the mindset is there at Meta. So those are the things of success. And then another aspect of success is we build up a lot of knowledge base, but do we really keep upgrading and using it? So we are on the constant lookout. As you may have seen from my three examples, what was our core strength? IGBT converters based on IGBT technology. We could have stopped there, but we looked at where else can I use this knowledge? I have this expertise. I've learned so much over the last 20 years as an R&D firm. Where can I use this? Where more can I apply this? So we keep expanding and applying this knowledge to other areas. And in those other areas, obviously, when we started, inverters were known. But in solar, you have to have MPPTs, you need to have other panels, integration, etc. So again, new things to learn. So again, your knowledge base increases. And the last measure of success is customer confidence. This is something that is extremely important because I may want to do 10 projects, but if the customer doesn't have confidence in us, we will do 0 projects. So this is again one of the successes of Meta, I consider. Coming to the takeaway of this whole discussion, the last slide, and I'll finish in exactly 1 minute. So innovation is a great catalyst for success as we see. It eventually leads to commercial success. Eventually is a keyword. So then innovation leads to indigenous products, which give certain advantages to the customer. Not many people realize this. It is dependence on costly imports is reduced. Everybody knows this. But they also get assured technical support within country. Long-term handholding for obsolescence management. This is very important. And I'll quote quick 2 examples here. When I started discussing with the Adanis on solar inverters, the CEO said, first things the CEO said, we'll talk about new inverters. Can you repair ours? Can you imagine Adani, CEO of Adani Green Tech, being worried about repair of inverters? Why? Because they had gone massively put in Chinese inverters. And today, some of those companies don't even exist. Forget about getting support from them. So a very key point here, long-term handholding and obsolescence management is something that can happen only if there is technology innovation in the country. And then getting small tweaks to suit our operating conditions, our specific requirements. Is that possible when we bring in imported products? No. Again, small example. Locomotives were imported from General Motors. Technology transfer was taken from General Motors. Locomotives started getting manufactured. Then Medha went and, as I said, control system was replaced by Medha. But still, General Motors' lot of fleet was running. Medha's fleet was running. And then suddenly, the broad gauge conversion in Castle Rock section happened, where the Dudhsagar Falls is. I think some of you may know. Between Karnataka and Goa, there is Dudhsagar Falls, and it's a very steep gradient. 1 in 37 is the gradient. So if you go 37 meters, you drop 1 meter. It's a very steep gradient for railways, even for road. So there, how to run trains safely. The driver said, well, if the train goes above 25 kilometers per hour, we lose control. It's going to go into the sand dump. It is going to derail. So railways had a simple request. Can you tweak the control system such that the driver puts on a switch when he enters that particular section? And when that switch is activated, the system automatically should put on brakes if the speed exceeds 25 kph. Now, for a control system designer, this is not a big feature at all, very small feature. But my ex-company and their competition, two more multinationals quoted $700,000 to $900,000 and a 9-month time frame to implement this. Then railway said, fine, you know what, we are stuck. What do we do? So they were having this dialogue. Meanwhile, Medha had a small fleet because we had just started outputting our systems. So we sent a section. We studied. We had a couple of discussions with RDO. So from there, over telephone, and we said, we can do this. So we implemented it with our engineers, R&D experts going with laptop in the section and upgrading software, and in 2 days and free of cost. This is the advantage we could give. So naturally, railways trust us. We could have charged them, we could have arm twisted them, but it's an important factor that we don't arm twist the customer, even when we know we have a very specific advantage. And then last point, just innovation doesn't work. Most startups would have been very successful otherwise. What we need along with innovation is the ability and willpower for long-term survival. Then also the focus on supply chain, robust supply chain, and good manufacturing facilities. And most of our companies sometimes have these, but they are not coordinated as a focused effort. And then there has to be a firm commitment to vision and a cause. There has to be passion. And then finally, there has to be an approach to provide a solution. As you could see in the Vande Bharat Express, we did not say we want to sell you our train control system or traction control system. We said, what's lacking for a solution for you? We'll bring the solution to you. So this, I think, is all I had to share about the story of Medha and the Vande Bharat Express. There are any questions, they're welcome.
Thank you, Vishwas, sir. Thank you very much, sir. I personally completely lost all the time, sir. Normally, I give the reminders to the speaker, gentle reminders on the chat box, but now when you stopped, I saw the time. So that very great presentation, sir. We are now open to question answers from the participant. It is a direct opportunity to engage.
Mr. Vishwas, this is Kaushik Sengupta from RSP. Let me, sir, congratulate you. It was an excellent. Even what Rajesh told, we were all mesmerized the way you spoke, and we kept on hearing. I have one question. When you talked about this Kavach,
sir,
your hands showed two engines approaching from opposite directions.
Yeah. Yeah.
Okay. Now, suppose if both the engines are in the same line in the same direction, that means one train is there already. Kavach will work in that case also, I believe.
Yes, it will. It will, because basically what Kavach system does is through radio controls, which are established on the tracks, the train, even at 160 kph, it actually senses where it is based on the barcodes on the tracks. And it's a magnetic pickup. So it knows all the time where it is, and it relays that information to the control center, and it gets information from the control center about the other train, whether it's coming from front or from behind. As long as they are on the same track, they will both apply brakes and stop.
This signal transfer gets transferred wirelessly or through physical optic fibers or anything?
No, initially it is, there is a combination. There is wireless, satellite, as well as fiber optic. So it's a combination of all three.
And the satellite is India's own or through GPS?
It is not GPS, it is satellite communication.
Okay, satellite communication. So chances
of inputs are taken, of course.
GPS is less.
Yeah, but we can't rely on GPS because, as you know, sir, GPS commercially available is less than 1 meter accurate. And sometimes railway tracks are side by side.
Exactly.
So 1 meter accuracy is not good enough.
Correct. Thank you, sir, for the answer.
Thank you, sir.
Thank you, sir.
Mr. Vishwas, it was an excellent presentation. I am Suresh Kumar from SAIL Safety Organization. We are at Ranchi. The last time I was traveling from Ranchi to Havda in Vande Bharat. So I saw your tag in the engine. It was a wonderful feeling. And now the driver there was telling ki every activity of ours in that panel is getting recorded, getting communicated to the people at Havda. And at the end of the trip, I'll be taken to task if I violate speed in any particular zone. Or could you please explain how that happens and how?
So there is something called onboard diagnostics. There's a module which sits in the microcomputer, which is a control computer.
Yes.
And it has ability to watch all the signals, everything, like if he presses the brake handle or if he presses the horn, or if he in fact the concept goes even before that. So suppose the driver, do we all know how it is detected if the driver falls asleep? Earlier it used to be a dead man pedal, so the driver had to keep pressing a physical pedal every 2 seconds or every 5 seconds, like time interval. And if for 15 seconds he doesn't press that pedal, then the brakes used to apply. So it used to be a mechanical dead man pedal system.
Right.
But then drivers would put a stone on it. They would do all sorts of funny things. They would hang a stone which will hit that pedal automatically. All innovative. People are really, really creative. But so then we thought all that is not required, because driver is continuously driving, right? And if he presses a horn or pushes the throttle handle or a brake handle or puts on the headlights, any action is recorded and taken as a live signal that he is doing his duty. If he falls asleep, he will not touch anything. So then the system will give an alarm first, wake him up. If nothing happens even after 20 seconds, then it will apply brakes. So this is a system already existing in our system, our control system. Now that same signals, everything that is being watched that the driver mentioned, gets transmitted through GPRS cards to a control server.
Okay.
So that's how that information gets translated, and we call it a locomotive monitoring system. So not only it is used for this purpose, sir, it is also a predictive maintenance system. So we can actually we have about 40 engineers, our own R&D engineers, sitting in a center, monitoring the entire fleets, seeing the condition, because locomotive also publishes health data. What is my alternator voltage? What is my engine RPM? What is the throttle position? What is the brake pressure? Everything gets transmitted. So these guys run reports and see anything abnormal, an alarm will come up. They will schedule maintenance then. They will advise the maintenance facility. So this is a paid service that we provide to the railways as a support service. Railways has the ability to do it themselves, but they say you guys are more expert at monitoring it continuously. You do it at a minor cost. We have done that. That's how the driver is mentioning that everything is known in Havda.
Okay. Thank you.
Hi, Mr. Vishwas. This is SNM Rao. Yeah. One thing I would like to say is, yes, even SAIL is associated with Vande Bharat, because we supply entire stainless steel, what is being used in Vande Bharat for sidewalls, end walls, roof, etc., etc.
Yes.
And my question here is, what I understand from the ICF when we visit, normal LHB coaches, whenever it comes for a repair and maintenance, each coach can be sent it to the workshop and repaired. Whereas in Vande Bharat, because of its complicated communication system, entire train set has to come. You cannot replace one coach or one coach in between.
Correct, sir.
Does it not restrict the repair and maintenance? Because there is a problem with one coach. Entire
Right,
set of 16 coaches has to come to workshop.
Understood. You're right, sir. There is a trade-off. So this was envisioned by the ICF team right in the beginning. And so if you look at the traditional maintenance cycles of LHB coaches and the quality of the components used there versus what has been used on Vande Bharat, the maintenance intervals are enhanced significantly. So this train runs between Varanasi, the first train set, sir. I was monitoring it closely because I was very interested in the technology, though it was not my area at that point of time. I was looking at defense and solar and all that. But since our engineer, I used to talk to our service engineers. I said, what is the maintenance cycle? So what do you do? So they say, sir, 6 दिन हम कुछ नहीं करते. 6 days, there is no time to do anything. The train comes to Varanasi, goes back to Delhi, immediately starts back for Varanasi. 6 days it runs like that. 7th day, typically I think it was a Tuesday or some day was nominated. 7th day, visual examination. Nothing is to be opened. Visual examination, safety examination, downloads. That's it. And like that it runs. So it will be a month or two before the first maintenance small activity is due. So compared to LHB coaches, that cycle has been already elongated. This is my understanding. So you're right, sir. I mean, ultimately, there is a trade-off. Suppose we start taking off the coaches, it is possible. But again, you have to be very careful. If you damage the connectors, if you do wrong connections, again, it will be a major headache. So I think they have made a trade-off and said, fine, this is acceptable, provided my maintenance intervals are more than the normal LHB coach.
My second question is, since already you are into this Vande Bharat, what about your vision for this metro? Because every city is coming with metro.
Yes.
Alstom and Bombardier is the only,
Correct,
because
sir.
both are the one company now. There's no
Correct,
two
sir.
separate companies.
Correct, sir.
So it is kind
So-
of monopoly. Are you working anything towards that metro
Yes,
coaches and
actually,
propulsion
sir, we
system?
have been ready for metro, I would say, for more than 5 years now. Unfortunately, when metros were introduced in India, they set a qualification criteria for propulsion system as 10, and that blocks us. It is funny that we are running the Vande Bharat train with our systems. I mean, we are not running. Our systems are actually working in Vande Bharat trains, but metros we are barred because of the qualification criteria. So we are patiently waiting. I think by next year we'll qualify. You will see Mela coming into metros because theoretically the system is the same. We have done Kolkata Metro already.
Okay. Yeah.
Calcutta Metro did not come under the standard Indian Metro initially. So we had already done Calcutta Metro upgrades with our system.
In fact, I am proud to announce that
Metro
first metro
started-
in India,
Yes,
which is
sir.
Calcutta Metro, steel was
Yes.
supplied from Salem Steels. That is
Yes.
our stainless steel.
Yes, sir. So we have, I mean, SAIL is a very, I really admire SAIL because whenever I see, I know because of my background in aeronautical engineering and all, metals is something that dictates a lot of products. So I'm proud that, SAIL is one of the companies which has a variety of products in steel and other areas. So that's extremely good to see. I used to, in fact, when I was based in Africa, I used to tell ArcelorMittal at that point of time, executives used to come into railway meetings. So I used to tell them about SAIL. Because they were very curious where Indian Railways, how do they manufacture? So I used to tell them that SAIL supplies a lot of steel. So I've been an admirer of SAIL for
Thank
a
you,
long
sir. Thank you, sir, for being a brand ambassador of ours also.
time. Yes, sir.
Any more questions, sir, or in the chat box also? So we have one question in the chat box, sir. Can I
Yes,
read
sir.
it?
1 second. Let me see.
Hmm.
Can you please read it?
I will, sir. How to make quality management system move from certification to support real business outcome?
Okay. All right. So I would say the aspects I talked about, like customer trust and quality management, go hand in hand. So I said it is not just certifications, but what we do is we do active feedback sessions every month. We monitor our quality, and then we give that feedback to R&D and as well as marketing units. So that completes the cycle. And we can just not make quality a paper exercise, but it becomes infused into our design processes and into our customer support process. That is something that will help.
Thank you, sir. Thank you, sir. Sir, we wanted it to continue more, but as we started the session, sir, it's a Puja week also, and just last question, sir. Okay,
Sure.
it's in fact a comment, sir. So sorry to bother that, sir. So I don't want to take much more time of our seniors also. They are also busy. Have a very busy schedule. So we have listened to a great story from a great personality also, but it's very also important to imbibe and internalize it. and how the sale can take a benefit from it. To take a cue forward and also to summarize, sir, may I request again Sanjay sir to please give a short summary of the proceedings, sir.
Thank you, Rajesh. I don't think I need to do much to summarize. It was so lucid and so clear.
Please, sir.
But thank you once again, sir, for giving us a masterclass on managing innovation. For me, this was really a masterclass on managing innovation and driving home the clear conviction, not only about the why and how, the what part of, how innovation can drive success and how innovation can drive long-term success. And also helping us understand the process of how do you make innovation sustainable, how do you make innovation collaborative, and how do you create a culture which sustains that, which supports that innovation. And how at the end of the day, it's ultimately the inherent capability and talents of the people and their passion which drives. And I really like that slide about measures of success, where you finally said all these things are byproducts. So getting that conviction through to our people was something very great. We learned a lot of practical insights on how to manage innovations. And after a long time, we have had an engineer talk about an engineering subject very clearly and not talk about leadership and things like that normally talk about, but still get the message through. The essential is still about people, but you talked about the practical brass tacks of how things are done. And that was very fascinating for us. And we look forward to, frankly, we look forward to more such interactions. We'll figure out if we can get you here sometime whenever it's possible for you.
Yes, sir. It was my pleasure to be
it was
able to interact.
An honor and a privilege. And on behalf of all the participants and on behalf of SAIL, I'd like to thank you. And I once again like to thank Professor Awasthi for ensuring that we were able to get connected. And figure out a common time. And I'd like to thank all the participants who are our executive directors and chief general managers and driving a lot of workplace innovations in our own organization. And we are planning to take our organization to the next orbit. Thank them also for their active participation. I'm getting a lot of feelers about how great this session is. And wish you all a very, very happy puja, and let's have a great festive season. I think that's all I'd like to say at this point of time. Thank you very much.
Thank you, sir. Thank you, sir. Thank you all, sir. Thank you, Vishwas, sir. And
thank you, sir. Wish you all a very happy puja. Namaste, and I do look forward. Please feel free to send out any questions to me, and I do look forward to further interactions if required. And in person would even be better.
Sir, we would love that, sir. We would love that, sir. Thank you, sir. Thank you, sir.
Rajesh ji, just one small request.
Sir, please.
A couple of comments extra and some questions there as well. If you can pass it on.
I will, sir. I will. Sir.
We will pass it.
Okay, I will just.
Rajesh, वो questions को जरा copy कर लेना.
Okay. So there is one last question, sir. There are comments, sir. There are good number of comments, even in my personal chat box and even in group. Great session, insightful. Even a comment that we can collaborate on EV technology for our HEMM. One question, sir.
Yeah.
I will read it, sir. We are using version 3 of WDS6 locomotive. All electric controls is quite fine, but first notch movement of the locomotive is not smooth like the old version of WDS6 locomotive.
Okay. All right.
Have you got this type of feedback from steel plants? Are you working to improve it, sir?
WDS6 is not, it's a hardwired system which is not done by us, frankly. It's a very old system which has been there. So what I would recommend is you can go with battery electric locomotives now. We have done 3 battery electric locomotives in the US. We are getting great feedback from it. So we can discuss. And I'll certainly discuss with our team and try to, can you send me a copy of these questions? So I'll respond to this also and provide some more feedback on this.
I will, sir, over the mail, sir.
Because I mean, I don't want to pitch electric things. The basic question must get answered. So I will interact with our service teams and get you feedback on that.
And with your permission, can I share you, sir, if someone asks with your contact?
Yeah, please do.
Okay,
please.
Thank you, sir.
Please
thank
do.
you, sir. So thank you all, sir. That's all. Professor Awasthi, sir, shall we close it, sir?
Thank you, please. Yes, thank you.
And thank you.
I would request, because for me the most interesting comment was by Pankaj Priyaji, who said we can collaborate on EV technology for the HEMM work.
So that's where
We're
Thomas
already
Awasthi comes in. Yes.
So we're already, working with Medha on, implementing pilots in various mining sites. So I think this is a great opportunity to explore work with SAIL as well.
True.
Sure,
Thank you,
sir.
sir. Thank you, sir.
Thank
Thank
you.
you also.
Thank you and have great holidays.
And happy Puja.
Happy holidays to everyone.
Thank you.
I will now close the meeting. So thank you.
I'll log off, sir.